In this tutorial, we'll be talking about linear motion. Now, it's very important for us to understand the terms that will be frequently used in this topic. Number one is the term speed. Now, speed may be defined as the rate of change of displacement with respect to the surrounding of the image. So, write these notes. The speed of an object, that's object, may be defined as its rate of change of displacement with respect to its surroundings, Okay, so that's the definition of speed. We are going to be talking about speed. The speed of an object or a body may be defined as the rate of the change of displacement with respect to its surrounding. Okay, so how it's changing with the surrounding is what we may define as speed. Number two, we have to define velocity. Okay, we have to define velocity. Very important. We have to define velocity. What is velocity? It's another term that we are going to be constantly using. So the velocity of the body may be defined as its rate of change of displacement with respect to its surrounding in a particular direction. So the velocity of a body may be defined as the rate of change of its displacement. Okay, with respect to its surrounding in a particular direction. Have these notes in your book. Okay, so we can tell that now the difference between speed and velocity is that velocity is a scalar quantity because we are defining it as the rate of change of displacement with respect to a particular direction, whereas the speed is simply regardless of direction. So it's very important for us to know these terms. Very important. The other definition that we need to know is acceleration. We are going to be using this term often in this topic, acceleration. So acceleration is simply the rate of change of velocity. The rate of change of velocity. It's as simple as that. Then we have number 4, uniform acceleration. Okay, now uniform acceleration simply means the change of velocity is usually equal to the change of time. So the magnitude with which velocity changes is equal to the magnitude with which time changes. So if velocity changes by 5, let's say it was 0, 5, 10, 15, those intervals, and time is changing 2, 4, 6, it's uniform. So that's what we are trying to say. Then there's also variable acceleration and so forth. Okay, so we are saying uniform acceleration is when the body moves in such a way that its velocity changes in equal magnitude in equal intervals with time. So a body is said to have uniform acceleration if the rate of if the rate of change, how do we define it in a proper English? If the rate of change of velocity is uniform. Let me not use the word uniform because we have used it here. If the rate, okay, if the changes in velocity, okay, if the changes in velocity is equal to the changes in time interval. So the graph will look something like this. So where you have velocity and you have time. So what happens is when velocity changes from there to there, time will change uniformly from here up to there. That's why you have got a straight line, which is a gradient. After uniform acceleration, we have got a variable acceleration. Now, variable acceleration is simply the opposite of uniform acceleration. In short, how velocity is changing is not equal in magnitude with how time is changing. So you find that velocity is changing in a bigger moment, time is changing in a shorter moment. So one example that we can give in a graphic representation is this, where you have a velocity and here you have got time. So you find that time is changing in short intervals. Let's say that then velocity changes in big intervals, which will make the line here not to be straight. Then the fourth definition that we are going to talk about is retardation. Now, retardation is simply the opposite of acceleration. It is also sometimes called the deceleration. So when you have got a velocity time graph, retardation will actually look like that, where you have got time here and you have got velocity over there. So this is what you need to know as we begin this journey into linear motion. These definitions are very, very important. Let's just have a look at them in a summary pattern. So number one, we talked about speed, which we said is the rate of change of displacement with time. Now, this has got no respect with time because speed is a scalar quantity. Number two, we talked about velocity. We are saying velocity is the rate of change of displacement with time in a particular direction. It's a vector quantity. Number three, we talked about acceleration, which we said acceleration is simply the rate of change of velocity. Then we have talked about uniform acceleration, which we said when velocity is changing in equal magnitude or equal intervals with time, then we have got uniform acceleration. Then the fifth one, we talked about variable acceleration. So we are talking about velocity changing with respect to time, not in equal intervals of time. So perhaps when velocity changes, the first time it will change in 2 minutes, the next time it changes to change in 4 minutes, that is a variable. Then the sixth one we talked about is the retardation, which is also called deceleration. It's a negative acceleration value. So very important for you to know these terms before you proceed anywhere, because these are the terms that we are going to be often referring to. So see you in the next tutorial.